Welcome back my dear friends. Today we were diving into the fascinating world of ship construction. Whether you are a maritime guy or a sailing seafarer, understanding shipbuilding terminology is essential for navigating this complex field. From the hull to the keel and everything in between, we will break down the key terms that every ship guy should know. Are you ready to set sail on this educational journey? Yes, as this video is dedicated for maritime aspirants, so I will go with the syllabus and I have given the latest syllabus of this part in the description box. So go and check after video. Let me give you a brief view about what we are going to see in this video. So a ship, explaining the following principal parts of a ship, which includes bow, stern, midship, port, starboard, bulbous bow, hull, main deck, bridge, accommodation, mainmast, foremast, jack staff, ensign staff, engine room, steering gear room, funnel, upper deck, mast house, crane, cargo hold, hatch combing, hatch cover, booby hatch, bulwark, gunwale, mooring winch, windlass, fair leads, rollers, cross deck, poop deck, forecastle deck, tanks, forepeak tank, aft peak tanks, double bottom tanks, stores, chain locker, propeller, rudder, keel, gangway, porthole, bulkhead, collision bulkhead, manhole, weather-tight doors, and forward perpendiculars FP, after perpendicular AP, length between the perpendiculars, amidships, length on the waterline, length overall, baseline, molded depth, beam and draft, extreme depth, beam, draft and air draft, camber, rise of floor, tumble home, flare, shear forward, shear aft, steam rack, parallel middle body, entrance and run. Load line including the plimsoll mark for a ship, labeling them with their horizontal and vertical distances, drawing a draft marks over a 2 meters range, explaining the draft marks, plimsoll line, deck line, load lines and freeboard. Importance of the load line, gross tonnage GT and net tonnage NT. Standard steel sections of a ship like flat plate, offset bulb, equal angle, channel, T, frames, floors, transverse frame, deck beam, knees, bracket, shell, plating, decks, tank tops, stringers, bulkheads and stiffeners, pillars, hedge girders and beams, combings, bulwark, shell expansion plan, frames and framing numbers, the deck edge showing attachment of shear strake and stringer plates, double bottom tanks, sounding pipes, air pipe and ventilator. So let's start them. So guys, let's start the simple diagram of a ship with showing the principal parts and some important parts. So starting from the forward, we will see the bulbous bow, double bottom tanks 1, double bottom tank 2 and double bottom tank 3. So these three are the double bottom tanks which we will use for the storage of ballast. And this is the propeller, the rudder, aft peak tank, steering gear flat or steering gear room, ensign staff, poop deck, funnel, mainmast, bridge, accommodation, crane, hatch. There are 3 holes, upper hold 1, upper hold 2, upper hold 3 and lower hold 1, lower hold 2, lower hold 3. So engine room first deck, engine room ECR platform, engine room third deck and engine room bottom platform. So gangway will be look like this. Spurling pipe will be located somewhere here, windlass, foremast, jack staff, bosun store, anchor plus hose pipe will look like this, and chain locker, forepeak tank. So we'll move to the next video. Guys, you have to draw all the diagrams and you have to learn the definitions. So in ship construction, I have already given all the diagrams and I have written all the definitions, so there is no need to explain everything. So guys, this is the plan view or the top view of the ship. So this is the port side, that is called the left side of the ship. Starboard side will be the right side of the ship. So aft will be here, forward will be here. Forecastle deck, poop deck and manholes will look like this. Once you go on ship, you will find the manholes. And if you imagine your ship from the top side, the manholes will something look like this. Okay. So next will be the camber, curvature of decks in the transfer direction. You can refer to the diagram to understand the definition. Rise of floor will be the rise of bottom shell plating line above the base line. This rise is measured at the line of molded beam. The inward curvature of the side shell above the summer load line is called tumble home. Shear will be curvature of decks in the longitudinal direction. Steam rack will be inclination of the steam line from the vertical. Flare will be the outward curvature of the side shell above the waterline. Parallel middle body, the part of the ship where the transverse cross section, means the port and starboard, remains constant in area and shape for a certain distance near the middle of the ship. This is common in large ships that carry bulk cargo. Guys, you can see parallel middle body will look like this, equal in shape and equal in area. Entrance and run are two different things. The immersed part of the ship that located forward of the parallel middle body is called entrance. You can see the shaded diagram. And the immersed part of the ship that located aft of the parallel middle body is called run. You can see this diagram. So types of views are plan view, profile view and cross-sectional view. So plan view will be the top of that thing, profile will be the side view, and cross-sectional view once you cut the anything from into halves, so you can see their cross-sectional view. So in the shipping lines, plan view of a ship will look like this, profile will look like this, and cross-sectional will be look like this. So profile view and plan view of a ship. So this is a general cargo ship. You can see this is the profile view and this is the plan view. Again same but something different. So there are types of keel: flat plate keel, duct keel and hull plating. So there will be a keel plate, center girder and inner bottom. Again center girder, inner bottom and keel. So these are two different kinds of keel type: flat plate keel and duct keel, and there is one more keel called the bar keel. So ship side structures and deck beam area of gunwale and rounded shear strake. So this is the cross-sectional view of a cargo hold. You can see the water ballast tanks at the upside and the downside, and in between them you can store your cargo. Again the cross-sectional view of a cargo hold with some more details. So this is the wing and double bottom tanks with the ship side. So you can see these are the wing tanks, that is called hooper tank, upper hooper. This is the lower hooper, and these are the double bottom tanks, and this is the cargo hold. So everything is labeled. You have to draw the diagram and you have to label it. So this is the cargo tanks. This is a tanker ship. So you can see the water ballast you can store here, water ballast you can store here, water ballast, duct keel and then cargo tank. So there are some definitions you have to read. I will just go by with their names: deck girders, longitudinals, web frames, bracket, beam knee, pillar, plating, bilge plating, tank top and double bottom. So deck girder stands for the longitudinal members that combine with the beams to form the longitudinal framing of the deck. So guys, longitudinal framing means longitudinal frames stands for from the forward to the aft. They provide strength to the ship from the forward to the aft, and transverse framing provide the strength to the ship in the port to starboard direction. So longitudinals, a very general term to identify any small longitudinal member that can be used for several purposes. This term is used more specifically in longitudinal framing. So web frames, oversized members that replace a frame at a certain locations on a ship. Bracket will be a general term that identifies any part used to connect two members. Beam knee, bracket located at the end of deck beams that connect the beam and frame to the shell plating. Pillar will be vertical member inside the ship that connects the deck to the ship's bottom, where it is installed between two twin decks, especially around hatches. They are quite bulky and complicate cargo handling inside holds. So bilge plating will be plating. The plating of a hull is the series of plates that form the watertight shell of the hull. There is bottom plating, deck plating and side shell plating. So bilge plating will be longitudinal plating that connects the side shell plating to the bottom plating. Tank top, watertight series of plates attached to a ship's bottom framework. Double bottom, the double bottom is a watertight space between the bottom plating and the tank top. Its height varies according to the size and type of a ship, but it is generally between the 0.75 and 1.5 meters. A double bottom is divided into several watertight compartments by watertight floors and girders. These compartments can be used to store fuel, oil and ballast water. They are often used to adjust a ship's list and trim. So this is the main deck connections. You can see the bulwark stay, beam knee, side frames, hatch and beam, pillars, deck plating, hatch side girder, transversely framed deck. So this is a transversely framed deck, hatch combing, deck plating and deck beams. So in this figure you can see the plating, stiffeners, stringers and stringers structure omitted for clarity. In this figure you can see the deck beam, web frames, side shell plating and tank side bracket. And again a cargo hold cross section view in which frames, brackets, upper deck, cross deck, tank top, double bottom tank, side shell, hatch combings are located. So purpose of various stiffeners will be longitudinals that run along the bottom plating and provide significant strength. Deck girders also longitudinal, which again contribute to the longitudinal strength of the ship. Longitudinal strength of the ship means the strength that is provided by the longitudinal frames from the forward to the aft. Stringers running longitudinally on the side plating and where required along the inner side. Plating for a double hull ship, frames which run vertically up the side plating, floors which are deep transverse frame on the bottom plating, deck beams which support the deck transversely. So this is a picture of a bulk carrier ship in which various stacks, frames, beam is shown. You can consider that this ahead of this bulkhead there will be a bosun store, a 4-peak tank, and after and beside this there could be a general cargo hold. So this is a real example or real picture of a ship's double bottom tank in which you can see the anodes, because we will store the salt water or we will take the salt water ballasting. That's why anodes is required. Ballast pipeline is given, brackets are given, web frames are given and longitudinals are given. So this is the diagram which you have to draw if there will be a question of aft peak tank and rudder or propeller. So this is the double bottom tank diagram or double bottom construction. The simple one, double bottom tank diagram, transversely framed double bottom tank. This is the transversely framed double bottom construction. Longitudinally framed double bottom construction. Ventilators, air pipes, sounding pipes. So ventilators used in accommodation, stores, holds, body spaces, engine room for exchange of air. Air pipes used in tanks, ballast for fuel, for exchange of air. Liquid can come out of tank, but outside seawater cannot enter the tank. Sounding pipes to take the soundings to measure the height of a liquid in the tank. Temperature pipes will be to measure the air temperature of a hold or cargo temperature. So there are 1, 2, 3, 4 types of ventilators I am shown. First one is the cowl ventilator, second is the mushroom ventilator, third is the window type ventilator, and fourth will be the gooseneck ventilator. And types of ventilation, there are 2 types of ventilation, natural and forced ventilation. So real picture of a ship showing the mushroom and gooseneck vents. So this is the air pipe, how air pipe works on a ship. So the above figure shows the design of an air pipe cover. In normal condition, the bowl remains at the bottom of air pipe head and the tank breathes in and out through the vent. However, in the event that the air pipe is submerged, then the bowl floats up and closes the opening at the top, thus preventing any water from entering the tank. So this is the cross section view of an air pipe head. You can understand how the water is coming and going inside the tank and how the tank breathes in and out. So air pipe is a pipe fitted to the ship's tank so that the air exchange take place when any liquid filled into the tank or pump out of the tank. So the air pipe extends from the top of the tank usually to the upper deck of a ship. The top of the air pipe has a head where a wire mesh is fitted to prevent naked light to enter the tanks. A non-return valve is present on the head of the air pipe so that seawater cannot enter the tank from the outside. So you can see there is a portrait of the sounding this gentleman has standing on the main deck and he has a sounding tap in his hand. He has started lowering the striker, and once the striker will touch the bottom, he will feel and he will calculate the reading. So sounding pipe caps. Sounding pipes covers come with various designs. That shown above is a sunken cap type. Generally the cap is made of brass. It can be normal cap type also. Use of striker plate. The tank bottom structure is not damaged, hold due to the repeated striking of the sound rod. When the plate wears out, same can be replaced or repaired. So this is a sunken cover with key slot. You can see there is a key slot, so whenever you have to open, you need a key to open this. And there will be a striker plate. So once your bob will come down, so it should not again and it should not touch the ship's bottom. Otherwise there will be a hole. So to save that hole and to save that a large amount of money, there will be a striker plate. Once the striker plate will be completely decoy, you have to change it. So there are self-closing sounding cap, sounding rods and sounding tapes. Sounding pipe is used to take sounding of a ship's tanks, that is, obtaining the height of a liquid inside ship's tank. After getting the height of a tank, the value is inserted in a sounding table to obtain the volume of the liquid at the present trim of the ship. At the bottom of sounding pipe is a striker plate, which prevents damage to the tank structure when a sounding rod strikes the bottom of tank. The pipe is covered by a cap at the top end so as to prevent any foreign particle to enter the pipe. Clamps are used at various lengths along the pipe so as to prevent the pipe to vibrate and get damaged when the ship is in motion. So you can see the cargo hold bilge and strum boxes. So this is called the rose box or the strum boxes. This is the manhole cover. These black particles or black you can say these are the gaskets. Now will be the load lines. So this is the LR, Lloyd's registers. Load lines will be the WNA, Winter North Atlantic line, 50 mm below to the winter is shown in vessels not exceeding 100 meters. So in length, trading in North Atlantic Ocean during winter season. The exact limit and dates of winter zone in the North Atlantic are given in the load line chart. All the lines are 25 mm thick. Lines are welded on the shell plating. Lines are painted white or yellow on the dark background paint and black on the light background paint of a ship side. The upper edge of each load line indicates its exact level. There is a note. Draft is measured considering lower edge of the draft marks. Top of deck line meets the top of freeboard deck. Directly below deck line there is the one mark called plimsoll mark. Plimsoll line and summer load line is at same level. When water level is at same level of the top part of summer load line, then ship is said to be in floating at summer draft. In summer zone, ship cannot be loaded up to this line, top part of the line. The center of this load line disc is at the middle of the upper edge of its 25 mm thick line. The vertical distance between upper edges of S and T means summer and tropical, and winter is 1/48 of the summer draft. Distance between the F and S, TF and T is the distance equal to the freshwater allowance of the ship. So there is the draft marks in meter and feet. So on the left side in the black box you can see in the feet, and on the right side you can see there is a meter and feet also. Draft marks in meter and feet. So this is how you have to read the draft marks. Now guys, some definitions. Forward perpendicular, this is represented by a line which is perpendicular to the intersection of the design load water line with the forward side of the stem. After perpendicular, a line which is perpendicular to the intersection of the after edge of the rudder post with the designed load water line. This is the case for both single and twin screw ships. For some ships having no rudder post, the after perpendicular is taken as the center line of the rudder stop. Length between perpendiculars. This is the horizontal distance between the forward and after perpendiculars. Length overall means length measured from the extreme point forward to the extreme point aft. So these are the dimension of ship and some definition drawings. So you can see there are a lot of things given: forward perpendicular, shear forward, forecastle, summer loaded waterline, freeboard, draft keel, after perpendicular, shear aft, midships, camber, depth, turn off bilge, keel, beam, shear, central line, flare, rack of steam. So again there are some definitions: baseline, molded depth, molded beam, molded draft, extreme draft. Bulkheads. Watertight bulkheads. A watertight bulkhead is a transverse bulkhead mounted on the tank top, and it must extend right to the uppermost continuous deck. So watertight bulkheads are installed to divide the ship into the watertight compartments and thereby limit flooding if the hull plating is damaged, improve the transverse strength of the structure, prevent distortion of the hull plating, support the deck girders and longitudinals, rigidly attach the tank top to the upper deck, greatly slow the spread of fire. So this is the corrugated watertight bulkhead. Corrugated means zigzag. It is not exactly in the straight line. It will be look like a zigzag if you see from the top. So bulk carrier cross section, and again bulk carrier cross section. It is from the motor vessel flare. So this is a container ship cross section. There are open floors and plate floor type double bottom tank. Sectional view of a cargo tank. So you can see the cargo tank, how cargo tank look like from inside. Longitudinal bulkhead, how longitudinal bulkhead looks. Transfer bulkheads, web frames, transverse, center girder and side girders. So next is GT versus NT. GT stands for gross tonnage, which means the total volume of all ships enclosed spaces. NT stands for the net tonnage, which means the space of a ship that is used to carry cargo. Ship registration fee, harbor dues, safety and manning rules are calculated on the basis of its gross tonnage, not on net tonnage. So you can refer to the diagram. So you can see net tonnage is the measure of the total interior volume of a ship's cargo spaces. So you can see only the cargo spaces has been marked. But for the gross tonnage, complete vessel has been marked. Shell expansion plan. A shell expansion plan is a two-dimensional drawing that shows the three-dimensional surface of a ship's hull. It's a plan that includes the following information: the size, shape and weight of the ship's shell plating plates, the connections between the plates, thickness of the original strake, the quality of the steel used, the seams and butts, the welding of the plates. A shell expansion plan is useful for marking the location of hull damage and finding areas for painting. So types of steel will be fret bar, offset bulb plate, angle bar, T-bulb, channel bar, T-bar. Guys, we have covered a lot of things. I hope this video helps you a lot. If yes, thumbs it up, comment, share. Rest you know what to do. Okay guys, we'll meet in next video. Till then, Jai Hind, Jai Bharat, Vande Mataram.